morning, students. In last class we will see what is meant by signal, what are the classification of signals, and what is meant by DSP and reflection. Now we have seen what is the operations on signals. That means if we have signal, every signal have some information. That information must be taken out. To take out that information, we have to apply some operations on it. Let's see what are those operations. First one, time shifting, time reversal, time scaling, amplitude scaling, signal multiplier, and signal addition. These are some basic operations which we have to perform on signals. Okay, let's see one by one what is the use. Coming to the time shifting, time shifting operation for the discrete time signal can be represented like this. Y of n is equal to x of n minus k. That means where k is the multiplier or any integer, based on k values it must be shifts. Shift means the given signal which must be shifted from either right side or left side. If it is shifted to right side, it is called delayed signal. If it is shifted to left side, it is called advanced signal. The delayed or advanced versions based on k value. If k is a positive integer, then the signal should be delayed or signal should be shifted to right side. If k is a negative value, signal should be advanced, then signal should be shifted to left side. Let's see an example. Similar case, if k is a positive integer, signal should be shifted to right, that is delays. If k is a negative integer, then signal should be shifted to left, that is advances. So if you see example, this is the signal what I have taken, x of n, which is start from 0, 1, 2. Amplitude is 1 on all cases. Now I have written x of n minus 2. X of n minus 2 means k value is positive value. Here what we have to do is x of n start from 0. That's why x of n minus 2, that means n minus 2 equal to 0. Why we have placed 0 here, sir? The original signal should start from 0. That's why n minus 2 equal to 0. Then n is equal to 2. That means the signal what I have to draw, that must be start from 2. That means it is start from 2, 0 to 2. Here we get 2 to 4. That is the x of n minus 2 signal. That means we have to take n minus 2 and we have to place the original signal starting value. If it is 0, we have to place 0. If it is minus 3, we have to place minus 3. Okay. That means this way we should find out shifted signal. Okay. This is x of n minus 2. This x of n minus 2. Similarly, we can find out n plus how. Let's see. So it is x of n plus 3. Same signal x of n, we should be shifted to advanced, that means right side. How we can get x of n plus 3? Similar way, n plus 3 equal to 0, we get n equal to minus 3. That's why the signal should start from minus 3, minus 2, minus. This is the original signal. It is right-sided signal. It is left-sided signal. Right-sided signal means delayed signal. Left-sided signal means advanced signal. That's why I said whenever k is positive, here n minus k, here we get n minus 2. That means k is a positive value. That's why signal should be shifted to right side. Here n plus 3, n minus k, that means n minus of minus 3. That means k value is negative value. That way signal should be advanced or left-sided. It is called time shifting operation. By using this operation, we can delay the signal, or we can advance the signal, or we can right side shift the signal, or we can left side shift the signal based on the operations. Okay. So next one, time reversal. Time reversal is nothing but time reversal of a discrete time signal can be getted by folding the signal with n equal to 0 axis. That means they have given one signal. You have to fold that signal based on n equal to 0 axis. How, sir? Let's see. Mathematically, y of n is equal to x of minus n. That means we have to place minus n wherever we get n. That means time reversal operation means in the given signal x of n, we have some n values. For each and every n value, we have to place minus n. So let's see. This is the original signal. What we have? 0, 1, 2, 3. At which positions? 1, 2, 2, 1 are the amplitudes. This is the graphical representation of the signal. Now we have to get time reversal operation. How we can get we have to fold the signal based on n equal to 0 axis. N equal to 0 axis ni base cheskoni we have to shift right to left and left to right. Here 0 to minus infinity there is no signal, that's why we will shift this 1 2 3 to left side, then we get minus 1 minus 2 minus 3. That means n equal to 0 axis is the base. By using that signal we should fold right to left just like a paper folding, right to left and left to right. Okay, what happened? Amplitudes doesn't change. Why? Because it's a time reversal operation. We will reverse time, not amplitude. Only the change is 1 2 3 becomes minus 1 minus 2 minus 3. Mathematically it should be represented as y of n is equal to x of minus n. That is called time reversal operation. Coming to the time scaling operation is get by replacing n with an. In the given signal x of n, if we place wherever we get n, we place an, we get time scaling operation. Time scaling operation majorly used for expanding the signal or to compress the signal. Like we in some applications photo size is very high. How we can do that? We have a photo compressor concept in Play Store. We will download that and we will compress the photo size, then we will should apply for the application. Similarly, if we want to signal compression or signal enlargement, we should go for time scaling operation. How we can do the time scaling operation means just in the given signal x of n, in place of n we have to place an. Okay, this is the mathematical operation. Y of n is equal to x of an, where a is the integer. Based on a value, sometimes signal should be compressed, sometimes signal should be enlarged. How, sir? If a is a multiplication factor, that means 1 2 3 4 5 6 like that, signal should be compressed. If a is a divisible factor, that means a equal to 1 by 2 1 by 3 1 by 4 1 by infinity, in such case signal should be enlarged. That means based on a value, signal should be compressed or signal should be enlarged. So this is the signal what I have taken, original signal A. It starts from minus 3 to 3, 1 2 3 4 3 2 1 are the amplitudes. Now I have to find out the new signal y of n is equal to x of 2a. Okay, how, sir? Just here start from minus 3 to 3, just place that value here, n equal to minus 3. If I place n equal to minus 3 in my equation, y of n equal to x of 2n, y of minus 3 equal to x of minus 6. Is there is any minus 6 value? No. So the minus 3 amplitude is 0. Next, if we take minus 2, y of minus 2 equal to x of minus 4. X of minus 4, there is any value? No. That means at minus 2 amplitude is 0. Next, n equal to minus 1. Y of minus 1 equal to x of minus 2. X of minus 2 amplitude is 2. So here we have to place 2. Next, y of 0 equal to x of 0, 4. Next, if we take n equal to 1, y of 1 equal to x of 2. X of 2 amplitude is 2. Similarly, n equal to 3, y of 3 equal to x of 6. There is no x of 6, that's why it becomes 0. That means we have to substitute all the values of x. Here x value is defined from minus 3 to plus 3, that is minus 3, minus 2, minus 1, 0, 1, 2, 3. At each and every place you have to find out y of n. Y of minus 3, y of minus 2, y of minus 1, y of 0, y of 1, y of 2, y of 3 based on this equation. What are the amplitudes we have? Those amplitudes must be presented here. If you see, it is from minus 3 to 3, but it is from minus 1 to 1. That is, signal should be compressed, where whenever a is multiplication factor. Okay. Similarly, whenever a is a divisible factor, then signal should be enlarged. Amplitude scaling. Similarly, amplitude scaling is also used to compress or enlarge the signal in amplitude manner. In the last example, we will scaling the signal in time side. Now we have to scaling the signal in amplitude manner. Mathematically, y of n is equal to a into x of n. Okay. Similarly, where a is the integer, based on a value, signal should be compressed or enlarged. But time and amplitude both are opposite in nature. Time must be in x-axis, amplitude in y-axis. That's why here, whenever a is a multiplication factor, signal should be enlarged. Whenever a is a divisible factor, signal should be compressed. Let's see one example. This is the signal x of n, minus 1 to 1, 2, 4, 2. This is the signal we have to find out. Y of n is equal to 2 into x of n. So here amplitude scaling means there is no effect on time. So minus 1 to 1, same time period. Whenever n equal to minus 1, y of minus 1 equal to 2 into x of minus 1. X of minus 1 is equal to 2. So 2 into 2 into 2, 4. Next 0 pedite 8. 1 pedite 4. Signal enlarges in amplitude way. Here amplitude is increasing. That's why it is called amplitude scale. If I take divisible factor, that means 1 by 2, 1 by 3 like that. Signal amplitudes must be reduced. There is no deviation in time period. Okay, only amplitudes will changes. Okay, from the first class onwards, you have learned how to addition, subtraction, multiplication, division. Those are the basic mathematical tools. So signal addition means we have to add two signals. Signal addition means must and should we have two signals. We have to add those two signals at each and every time instant. That's important. Based on time, we have to add given two signals at each and every time instant. And understand that point. How? This is just a graphical representation. We have given x1 of t, x2 of t. By adding dash 2, we get x1 of t plus x2 of t. We have given x1 of t, x2 of t. By subtracting those two, we get x1 of t minus x2 of t. Just general concept. Similarly, we can perform subtraction, multiplication, and division. Same concept. We have to add given two signals at each and every time instant. We get signal addition. We have to subtract each and every instant given two signals. We get subtraction. We have to multiply given two signals at each and every instant. We have to divide given two signals at each and every time instant. This is called signal addition, subtraction, multiplication, and division. Okay. That is about signals and operations on signals and classification of signals we will see in the last classes. Okay, now we should go for the systems. Why? Because DSP, digital signal processing, itself it is a system. We have to operate some signals and get some information from it, and we have to apply some information onto it. So system, you know that system is a device that can generate output for the given input signal. మనం ఇచ్చినటువంటి ఇన్పుట్ సిగ్నల్ కి అది అవుట్పుట్ సిగ్నల్ జనరేట్ చేస్తుంది. Examples in ECE we already studied: amplifiers, filters, all those are the systems. Systems can be represented by block diagrams as shown in the below figure like this. Generally it's a continuous time system. Here we have discrete, that's why it is called x of n is an input signal, y of n is an output signal. Okay, every system must be represented like this. This is a block diagram representation of a system. Just write a block in that right system. Input signal x of n, output signal y of n. Why? Because it's a discrete time system. How we can represent mathematically? It's a continuous in discrete. Y of n is equal to transformation of x of n. This is the block diagram representation, and this is the mathematical representation of system. Mathematically we could represent like this. Block diagram we could represent like this. Majorly what you have to know is system is a device which is used to generate an output signal for the given input signal. Okay. You know, again we have classification of systems. Here we didn't discuss about continuous time systems. Majorly we should discuss about discrete, because it's digital signal processing. Next, lumped parameter and distributed parameter systems, static and dynamic, causal and non-causal, linear and non-linear, time invariant and time variant, stable and unstable. All those are the classifications you have seen in SS. Let's see again. Discrete time system is one which operates on discrete time signal and produces discrete time output. Discrete time system is a system which operates on discrete time signals only, that is x of n, and produces discrete time output signals only, that is called y of n. Mathematically, y of n is equal to transformation of x of n. It's a discrete time system. X of n is an input, y of n is an output. Okay. Lumped parameter and distributed parameter system, the signals which are function of space. That means time, space are the independent variables. If it depends on only space variables, it is called lumped parameter systems. If it depends on a function of space and time both, it should be called distributed parameter system. static and dynamic. A system which doesn't have memory is called static. That means a system whose output depends on present inputs. Present inputs means at this instant of time, input మీద మాత్రమే depend అయ్యింది. That is called static system. A system is called as static or memoryless if its output at any instant depends on the input at that instant. That is called present inputs, not on past or future. That is called static system. Otherwise, the system is called dynamic system. That means dynamic system output always depends on present, past, future inputs also. Okay, this is the example for static. Y of n is equal to n into x of n. And this is the example of dynamic. Y of n is equal to x of n minus 1. Causal. The system is one which the output at any time depends on present and past inputs. Here, system output depends on present and past inputs also, but not on future inputs. This is the examples for causal systems. Non-causal system is whose output depends on future values also. That means dynamic and non-causal are almost all equal, whose outputs depends on present, past and future inputs also. This is the example of non-causals. Linear, you know that a system which obeys superposition principle is called as linear system, otherwise non-linear system. For discrete time system, this is the statement. The system which obeys that statement is called as linear systems. Okay, see, time invariant and time variant, as the name indicates, a system whose input-output characteristics do not change with the time. That means a system input-output characteristics doesn't change with time. That is called time invariant. If it is changed with time, it is called time variant. Okay. A system which obeys both linear and time invariant principles is called as linear time invariant principle. This is the case. A system which obeys this condition is called as time invariant system. Stable. A system is said to be stable if and only every bounded input produces bounded output. That means bounded inputs produces bounded output. That is called stable system, otherwise unstable system. Like this is a bounded input which start from one position and one in one position. That is called bounded within a region. If that given a system output like this, it means it is also a bounded. Bounded means there must be a region, starting point, ending point. Such type of signals we call as bounded signals. Bounded input produces bounded output. That is called stable system. Here if you see, this is a bounded input. System output, it's not a bounded, it should be like this, goes on. Bounded input produces unbounded output. Such type of systems we call as unstable systems. Okay, that's it for today's class. Next one we will see in the next class. Thank you.